Super. Welcome. For recording's sake, again, Harun, how are you doing today?
Yeah, awesome.
Awesome, man.
Great. Yeah.
Oh, okay. Super awesome. Uh, Venkat, welcome. So we're introducing, Harun is going to introduce us Spark Streaming. Streaming is all about, Manasa, welcome. Streaming is all about, instead of reading from disk, you're reading from streaming flow like Kafka, Event Hub, Kinesis. There are some softwares which publish the data, publish. But from where they get from IoT devices, some other areas. Have you heard the word called PubSub, publish and subscribe? Sairam, have you heard PubSub? Srinivas Sakamori, have you heard PubSub? Pub
Yeah,
means
we have it in an
published.
integration blocker.
Ah, super. Sairam, this concept everywhere there. In ERPs also. Srinivas Sakamori, you heard this? You publish and subscribe, right? So a lot of systems can publish the data and some systems can subscribe to that. So in between, some softwares will be there. Just a famous one is Kafka. And on the Microsoft, there is a software called Event Hub. They use the Kafka concepts only. So,
One question here. While he's streaming, maybe just can you give us while present explaining about it, can you give us an example like streaming means? Okay, suppose you're doing any just any monitoring or drone monitoring, you are recording that something. Okay.
Correct. Very good.
How you stream? Yeah, give us an example normally. Just
super. Very good. Say your company take Southwest Airlines. They say they have 1,000 airplanes flying at any time. So as a pilot project, they may take 100. They already started out of 1,000, some 200 airplanes. They want to track at what height going, what speed they're going, what temperature in it, all this information. So the aeroplanes will have IoT devices. Those IoT devices will stream the data to the system called Kafka. So when they stream a JSON files. Now, maybe next. Sometimes it need not be real time. They publish it. Now, again, after 10 seconds, they'll publish it. Another 10 seconds. Some people every 1 second. Some people do every 10 seconds, like that. They start publishing it. So those events are stored in the Kafka. Then from the Kafka, there is a software. This data will be flowing in the sense your Databricks will start reading it. So it's a reading continuously, reading continuously like this, continuously. So, but for you, again, it is a read, write.
Okay.
So it is a kind of if batch only. In the batch, what you are doing, Srinivas Sakamori, you are also doing every 1 hour, reading and writing it, reading and writing. Here you are doing almost every second. Got it? Then another use case. Good question. Your company has a e-commerce website. Customers are adding cart, checking out. So, some customers, even we many times go to Amazon, we add to cart, and we don't check out. Especially not Amazon, a lot of companies. Sometimes the site may have a problem to checking out. I add to cart and leaving the website. I add to cart, leaving the website. So what the chief technology officer, chief revenue officers want is they capture those events. Whenever people had to check out, they immediately stream that data before even checking out. So the data is added to shopping cart. When it added shopping cart, that shopping cart code will publish to an API, Kafka API. Oh, this person, even if it's a guest, even someone logged in, is checked out, not checked out, added to cart, added to cart, added to cart. Those data will be streamed into Databricks, and it is processed. As the data is being added into the e-commerce site, added to the cart, those will be streamed. So they'll be fed to dashboards. Dashboard in the sense it is processed in Spark and right into Gold table, and a dashboard is linked to the table. You know the dashboard. This many people are checking it, but adding to cart, but they're not checking out. So what is the reason? Is it a problem with our website? Or even they know how many are adding to the cart, how many are checking out? Is it because the price is big? Or do we need to send them the coupons? Why people are showing interest but not checking out? Is it because the taxes, we are adding more shipping cost? Like that, the companies take decisions. How does this sound, Srini Sakamari? Does that example help a little bit? At least a little?
Yes, that's really.
It's a good question. Subbu, generally, a very few people might have worked in these streaming systems because not many use cases exist. Even in ERP, some streaming will be there. They're not continuous streaming, just 10 events coming, you subscribe it. 10 events coming, subscribe it now and then. Right, Sairam? Maybe not too many. But whereas in analytics system, the streams will be continuous, lot of continuous. Some warehouses data, they'll be streaming it. Some shipping companies will be streaming it. There is some green tractors. What is that company name with this farm tractors?
John Deere.
John Deere, exactly. John Deere. That is. I'll share a link. John Deere. They have a lot of those tractors. They give contract. They stream the data. The use case is Srini Sakamari, Saira.
Maybe they'll see what exactly they're doing, how they are using these trackers. Means the purpose of this, the renting.
Correct. And that also give them, they run machine learning algorithms and see if any tractors need a maintenance before even problem comes, So it's a predictive maintenance. Even Southwest also does that. Predictive maintenance. Does this airplane need before getting the problem itself? Oh, this might get into problem in next 1 week. So they have a threshold. So like that, streaming helps feeds a lot of machine learning algorithms. That is fairly enough. Harun will show us technically, what does it mean by streaming? But it is very close to batch, interestingly. That is the power of Spark. You like it. I want everyone to focus. Anything anyone want to add? Any questions? Manasa, Shiva? We are going to do streaming. Streaming instance data is flowing. Okay, go ahead, Harun. Kiran, any questions?
This is one question. Just it's not relevant to ask you this question.
Please go ahead. No question is irrelevant.
Suppose if any location, suppose they're tracking all the information, something for tractor. Okay, means with this they can able to see the location, all these kind of things. But with the IoT live streaming, how they can check the performance? That's just curious to ask you.
Yeah, see, performance is what they
generic.
think-
Normally, if you
Yeah.
live streaming means just exactly where your location and what exactly where you are, all the demographics you can able to track that one. Okay,
Correct.
but the rest of the things with the IoT device,
Mhm.
you can able to track the functioning of any system. It's not only tractor or anything.
That is correct. They have a threshold, right? Like vibrations.
Mhm.
In industry, the turbine is rotating. If they have some, they capture the vibrations. They capture the temperature. They capture the certain sound aspects. They have a criteria. If the sound is more than this, it means its vibrations are more than this. Some rules are the domain experts knows the rules. Those rules are captured in the machine learning. But that's a good question. There are a lot of use cases we can study that, but let's focus on technical stuff first. How to read.
Srini, I have one question.
Yeah.
So it different than like IBM mQuery or jQuery like that, because that also do the same kind of the streaming, right?
The MQs you might have TIBCO. So those only publish, subscribe, in the sense they do small scale publishing, but the large scale is done by Kafka, Event Hub, cloud scale. We are talking about cloud scale. In the last old systems, those are IBM MQ series, that series, this series, all the systems. Those works in OLTP world. In OLAP world, the leading is Kafka. In the Azure world, it's a Event Hub. In the AWS, it's a Kinesis. Different software. But for you to know, your job is to read again ETL, same again ETL. So they give you, this is the Kafka. So now learn how to use the Spark, how to read it, how to stream it, see how the stream is. Harun will do magic, how to read it, again, how to load it into Delta tables, how to transform it. Your job is the same like Tirupati Pujari, doing puja, ETL. But instead of batch, now you'll be using streaming. When the use case is powerful, like Ambani, when Ambani visit Tirupati, this guy, you'll have a connection. So you will have more influence. Like that, you're also like a pujari doing a streaming. Then you go to customer, they will have a lot of use cases. But technically, it is the same. But we'll give you some sample use cases apart from what we talked.
So while reading that the flow of data, suppose if there is a break for any reason, how do they handle that break or loss of data?
Super awesome. You're asking internals ahead. Very good. Very curious. That is where the cloud streaming works. Is the way they do is every time they read. So in the Kafka, they will have a mark. I'm reading from here. I read up to this. There is a mark. Watermark. Then in the Spark area, they use the concept called checkpoint. So whatever they read, they will do a marking here. I processed this. I read this, I processed this. I read this, I processed it. Suddenly, boom, some failure happened for some reason. Some machines failed, etc. Then when the streaming process, it will have a mark. I read up to this, I processed up to this. So it will have a restart logic built into this in the platform, Saira. That's a great question. Does it answer at least fairly for now?
Yeah.
Okay. There is a lot of things, but let's start just like any alphabets. A, B, C. We'll start with alphabets. A, I, U, U. Then Gunintalu. Then words. Then sentences. A lot of things will come. Okay, let's start, guys. Okay. Venkat. Venkat, you feel good? Let's focus on this topic. This is very, very important, especially next 5 years. You'll be doing a lot of streaming work also. Manasa, hear this and tell to your friends. Say, don't hesitate. Tell to your friends, today I learned streaming. Keep talking, not just
Yeah.
movies. Not just movies. I know you talk about that movie, that politics, this politics, that restaurant, this restaurant, but that is all there. That is all there. But talk about today I learned first time streaming.
Yeah.
I didn't understand fully, but I am learning. It's but very interesting. Something like that. Be open up. Be
Yeah.
a song. Yeah. Go ahead.
Yeah. Thank you, Srini.
Yeah.
Okay, let's get back into the action. So we are talking about the Spark batch, right? So everybody can hear me?
Yeah, sure.
Yes, sir. Go ahead.
So we were talking about the batch for last few weeks, so where we are reading different inputs from files and from major we wrote read from the files, different types of CSV files, and then we will say we're going to read from JSON as well. There are other modes of reading data, like what Srini was talking about, the streaming, and then we were also talking about the various use cases, right? The first thing is why streaming. So what are the use cases why we have to use streaming, right? So if you go here, you're talking about the use case. Say for example, if you want to, there's a company ABC, and they are selling say refrigerators or whatever, or there is a show, right? There's a popular show that is going on, and then we want to know how the show is doing, right? How the movie or the show is doing well. What are the feedback basically we want to read when it is going live, or say cricket match or whatever it is, some event. Now, how do I get the feedback? So mostly the viewers post their feedback. So it can be on the Facebook, on Twitter, or there's a site where they leave reviews, or Instagram posts, right? Or whatever it is. So you get data that is coming in continuously. People are streaming on the Twitter, which is X now, or Threads, whatever, about a particular event or particular topic that is happening. So how do I make sure on the fly that what is happening? Okay. And then how do I make sure to take action on that? For example, let's say if there is a interruption in the event, or if there is a power cut that's happening or grid failure that happened during the event. So what kind of actions we can take live? So for those kind of use cases, that is an example, right? So what I'm doing, I'm reading the data from Facebook, Twitter users using this Spark Stream. So these can be come through Kafka or whatever. So the idea is the data is continuously coming in. People are continuously posting. Okay. Once you get that data, you read each of that sentiment or the what you call that post, parse that using some keywords, say good, excellent, whatever, which means good feedback, or say bad, worse, whatever are the the synonyms for say bad review, right? And then you do a comparison of how it is going. How many good reviews are you getting? How many bad reviews are you getting? Or what are the main reasons or concerns that has been put in there? And then you take batches of those sentiments, you write it, and then put in a dashboard on top of that, which is continuously say refreshing. So you can see the sentiment of the event or whatever in the real time. Okay, so that's the use case we're talking. Now, how do we get this data from all of this? As I said, all this data that is streaming in may be coming through a Kafka or whatever, which reads and posts to different logs. And then we are subscribing or reading using the Spark streaming. And then based on topic, where it is coming from, which server we are connecting to, take all that content, do our transformations, right? So we did in our batch, we did transformations, right? So take that string, parse it, search for whatever synonyms that we want. If it is good, add a new column with column you have seen in transformations and put rating or say, oh, what is the sentiment? Is it good or bad or worse? So based on the input you parse, you put, and then you write it, keep writing, appending to a table, all this inputs. Now, because you do a filter, we have to do a filter transformation because in Twitter, there are a lot of the data is continuously coming in from all users, but you have to only take which is relevant for your event, right? So you filter in the stream where there is that keyword called event, that event, whatever you're doing, if they have mentioned that event in the stream. Same with Facebook or Instagram, hashtags, right? That you read and process and filter based on those hashtags, what reviews are relevant to me. And then that's how I do the so how do you think get the trending, right? That's the best use case we can say. So trending top 10, trending right now. So how do you get the trending right now? How do you know what is trending right now? Because if somebody is reading all the data in live streaming, processing it and seeing how many messages or how many posts are mentioning that particular event or particular hashtag. So based on that, again, you process again your trending events on geography, right? What's trending in India may be different. What's trending in US may be different, and what's trending in Texas may be different. In Dallas may be different, right? So again, you can go at level of region, right, or domains, right? So what's trending in healthcare? What's trending in insurance? What's trending in music? So that all of this, the data is coming in. So how do you process that, right, to make insights of that data in the live? So normally, if you have batch, you get all the orders, you get the events, you process the batch, and then you do transformations. So that's post. The event happened yesterday, and then today you're doing all sorts of post-mortem on that and see what went well, what did not, right? And then you see corrective action. But things like, what's trending, what we can do right now is what we want to is done through the streaming use case. That's one thing. So what are the other use cases that we thought about? Srini was talking about the flight, right? So mid-flight, how we are getting that. So let's say they have sensors IoT and then continuously streaming the data. And there is some issue with one of the sensor, not sensors, but one of the parts is not functioning properly. And we are able to catch that because the sensors are showing some, say, unusual frequency of vibration, something like that. Now, in the batch, all the data is coming in. Now it's there in the database. Suppose I run the batch after 1 hour, and then I take that data and see, okay, there is some anomaly that is happening here, and then there might be an issue with the flight. We have to alarm. Okay, but by that time you have already been more than an hour or two that's gone. There might be some incident already happening before that. But there's a steep temperature rise or huge winds or whatever it is mid-flight. So how do you let them know? Right? Communicate with the pilots or whoever saying that, hey, we are seeing some issues with this, do an emergency landing or do a detour or whatever, right? Or some sudden storm coming in, which they're not aware of. So these kind of things. So we talked about IoT from the plane itself, when it is streaming, when there is some live monitoring, processing and dashboard coming up, and then there is some alarm going on based on what filters or what notifications that we have set. Say if the frequency of these sensors is going beyond 150 or 200, raise an alarm, send a notification. Now, when it is live, the sensors are coming in, the live data we are streaming, we are reading, we are transforming, and then we are doing aggregations. And when there is, the data is, say, more than 150 for any of those three sensors, then we raise an alarm saying that, okay, this flight, this sensors is showing this wrong, notification immediately to take action. The same thing with weather, right? So something, a storm is coming in, or a tornado, something is coming in. So how do you track? There's a weather uh, stations that are streaming the data. They're capturing the data again from the sensors, right? The wind speed and the temperatures and all of the geographical, whatever indicators that are coming. So you process that in real time, and then you predict where the storm is going to, right? So this is all happening in the real time. It's not like, we run daily batches. Yesterday the storm was here, today it's here. So we don't have the luxury of waiting that long because we can act immediately, right? So that's how there's the use cases for the streaming. The more softer ones that we talked about, which has business impact, like shopping carts and um, booking tickets, right? For example, so when you're doing a booking, say you are not able to process, like Srini has mentioned, you're not able to process the ticket. I was doing this in booking a flight ticket, not here in India. What is that? Book My Travel or something. So within 3 minutes, I got a phone from the customer center saying that are you trying to book something, you're not able to, because they had that logs where was trying to book something, the payment is not going through. That event is captured and put in the logs on the process, and they had that notification that coming in with the details, the phone numbers and everything that they contacted back and resolved and booked it. So what happens if they don't do it? I think, okay, this is not, the site is not working. Let me try from some other site. And then you're losing business, right? So those are the more softer or better business use cases. And these are the more serious cases where you can actually make a difference, avoiding some catastrophes. Does that help you visualize streaming use cases? Team?
Yes, Arun. I
Sarah,
understand.
Kaveri?
Yes.
Yeah, understand. Yeah.
Okay. All right. So, that's about the use cases, right? So now we have an architecture diagram from the internet. Just wanted to give you a high level understanding what we talked about. So server A, B, C. Again, let's say the logs are coming in. The events or logs that are coming in here, and they are pushed to a Kafka stream. We have different logs. So when we go through a high level review of Kafka, Kafka will have a different logs on topics. Basically, you can write to data from coming in different things, and then you do read this Kafka using Spark streaming, and then process and send it to any other Databricks Delta database, or which will again go into the gold layer. You write aggregates, and your BI will pick up. So this is very high level, so don't put too much meaning into this. Just wanted to show how this works. So we'll go back here and then talk about what streaming is in the Apache Spark, right? So as we said, stream data is coming in. So how do we process? How does Spark or the Databricks process that data? Spark streaming process that data. It keeps converting or adding that data into a unbounded table. It's called input table, which means the data is coming in at any interval. It takes the data stream and keeps adding those as the rows to this unbounded table. Now, at each interval, you read this table and see what is the data at that state. Okay. So when does the data read and write it to the unbounded table is based on your trigger interval. So you can set at interval because you're reading the streaming data. Again, it sets a micro batch. Streaming is not real time, it's near real time. So you kind of trigger, say, every second. Okay. So at first time is 0, you have this input. So you understand this unbounded table? See, all of this has a lot of questions when you do for certification. How streaming is implemented in Spark
Why
Streaming.
it's called unbounded table? Means it's on table, they're appending data to that, right?
Yes.
Is it specific as an unbounded?
The table does not mean physical table here. You don't see a delta table or whatever. It is a virtual or say in memory. When you define the stream, the data is continuously being added in the memory, which you can treat as a table. But whatever incoming data is getting appended to it so that you maintain the state of the table. Right? At each interval, you keep adding more data to it so that you can read.
Okay, like that we can create multiple unbounded tables. We have multiple unbounded tables.
No, it's not we are creating anything. It's just how it is Spark is implemented to read from the stream. We don't have to create anything.
We don't need, okay.
We don't need to do anything here.
So this data is temporary.
Yeah, this is temporary, right? So you cannot keep, say, 1 day, 1 week data, everything in memory in the unbounded table. So it is unbounded, but then you will have what you say watermarks or the time to live data you configure. After that, the previous data will be flushed out.
Oh, means it will overwritten the existing information.
No, the new data will be coming in. The old data will be deleted.
Okay,
which is not relevant anymore.
Is there any buffer time like 10 minutes?
That you can set. That configuration you can set how long you want to have the data in the form. See, for example, let's say I'll give you. So this is again the important question for certifications. So recently, when I did the data engineer professional certification, or sometimes in the associate also. Late arriving data, right? So which means, let's say I have an order that I send, or say some readings that are coming in at 1 o'clock. Okay. At 1:10, I'm getting an update on the same data. Okay. But at 1:15, the previous data came in. There was a delay. Okay. So 1:10, the data came in, but actually at 1:10, the previous data came in, which was the actual update on that. Now those are entangled, right? Now, when you want to write it, you want to consider both the rows, which one is latest, because it will have timestamp. So the data came in at 1:15, that is the actual original data. So which was actually coming in at 1 o'clock, but because of delay, it arrived late. So, but that is the first one. The data the order update that came at 1:10 is the latest one. So you have to treat based on those timestamps. But if you don't have that in the window, how will you do it? So you say it came after 1 hour. So what we will do is we will define a window to live of 1 hour. So whatever is there within 1 hour is considered as one window. And then you read all that data within that window in that batch, even if it is string. So you can go back and aggregate all the data for last 1 hour, where the late arriving data is already taken care of.
Okay, is there no memory limitation for this one in the Spark? Means it will overwritten based on the time or it will based on the memory?
Yeah, performance limitation, memory limitation. Yes, it's again depends on how much you define the checkpoint directory, right? Write ahead logs. It keeps writing all of this, the unbounded table onto your cluster or your machines, your cluster in memory or disk within that cluster. So the size of the cluster again should be big enough to handle the amount of data that is coming in, the volume of data that is coming in.
One question here. Normally, you're saying if any data latency, okay, maybe 1 o'clock data should come at 1:15. Okay, means at the time when the data was coming, it's with the timestamp of as 1 o'clock or 1:15.
The timestamp will be correct. So you have to just read when you're processing, you have to process based on the timestamp, not based on when it arrived here.
Okay.
that's when you will actually read the data that come at 115. That you read that first, and then you read the data that has come in at 110.
Mhm.
But because the actual timestamp of that row will be earlier.
Okay, got it.
Okay, so that is, we will see, and all of these is basically the concept that you have to understand and read. So this is more towards the certification. A lot of questions are based on this. So you have to understand how it is processed. The short question is, how is Spark streaming implemented in the Apache Spark? How is streaming implemented in Apache Spark? So you say this, the option is that you process the data stream as an unbounded table, and you read the data based on the window that is there.
Arun, one question.
Mhm.
So when it comes to this unbounded table, it's on a cluster, right? I mean, there's no
Yes.
way that this memory could go down, right? Yeah.
Yes. Yeah.
Okay. And what is the maximum retention? Because you have been working on it. What is the industry standard for the retention period of keeping those? I mean, just the maximum and the minimum limit. Is there anything as such, or just
Yeah,
that,
it will be
like,
mostly in
based on the-
hours. Okay,
Okay.
it will be 1 hour or
Mhm.
maximum 2 hours. But again, it depends on the volume. If I'm
Mhm.
not seeing huge volumes, I can have more retention period. If I am seeing
Mhm.
less huge volume, the lower retention period. Again, you also have these in the, when you say use Kafka already stores these events for almost like, again, the logs are there, the same thing they will have for almost like 1 week. That's when we said, like, if there is an issue, we can go back to Kafka, reset the watermark, and read from, say, that timestamp or 1 week, 3 days, whatever, and then replay the whole thing again, reprocess. So in the streaming, because it's memory and process intensive, we kind of keep it to the windows, 1 hour window or whatever, that time to live.
So Kafka archives these files, right? Once it's
Kafka
out.
has its own, no, Kafka has its own log retention period that we say. Whatever data is coming into Kafka, it automatically retains that data in the logs for a particular period, say default 7 days. After that, again, it deletes. Okay. So if any issues there in the streaming here, you lose data or memory issues or whatever, you can always fall back, go to Kafka, reset the watermark, and again reprocess that data. Then reread the data from the previous watermark. Right?
Great, thanks.
So here, yeah. So here we say take 1 week, whatever is the retention. So not even 1 hour or 2 hours is what we do the data time to live here. Okay, so let's see how it is represented here, the programming model. So here you see, I am saying trigger every 1 second, which means read the data from the stream every 1 second. So this is my trigger interval. Now at time t1, say at 1 o'clock, input is data up to t equal to 1. Now at t is equal to 2, so let's say 1 hour and 1 second, there is more data that is coming in here. So the data is increasing. And T3, there is more data that is increasing. Now, when you do the result, so this is the unbounded table that is increasing. When you do the result is same. See why the result is same? This is representation. Let's say the orders are coming in. At T1, I have 10 orders. At T2, I have 15 orders. And at T3, I have 20 orders. Now, in the result, I'm saying, what is the aggregate order amount? Okay. So at T1, if I calculate for 10, or say order amount, total order amount. At T1, the order amount for 10 orders might be, say, 100K. At T2, there are more orders. When I do the total order amount, it may be 150K. But what is the data? The data is just one row. I'm aggregating. If I aggregate 10 rows or if I aggregate 100 rows, I will anyway get only one row, right? It just says this is the total order amount at this time. Now at T3 also, if I do aggregate, the amount will increase, but the data will be same. One row. I will get one row saying, okay, the order amount at 103 is this amount. Get timestamp and order amount. So basically, you are doing aggregations live in the streaming. And then you're writing that onto the, your say gold layer or whatever. So you will have all that cleansing, filter, all of this here, aggregations. And then you write output say gold layer where you can go and see the dashboard. Now, we said, right, on the gold layer, what we do, we write the aggregates, but we always kind of merge or overwrite. So basically, it keeps overwriting. Or if you want to have history, you can say at each time, if you want to do a time series, at each time, what is the aggregate amount, total amount, or average amount, whatever you want to do. But this is how the data is arriving and then how you are processing. Okay, good. Any questions here? I will show you. So we'll talk about the actual data to visualize what T1, T2, T3 is. Here, CAD,
second time T1 and time T2. For example, you said that aggregate the data. So when it comes to time 2, is it aggregate T1 and T2 or only T2?
T1 and T2. That is why you have more data here, right?
Okay.
So that's again defines if my window interval. So at T2, I have removed the data at T1, then it will not be there in the aggregate. So that's what you define. At what window interval do I need to have the T2? So let's say if I'm doing daily aggregates, then my window is 1 day. I need to have all the orders in the window for 1 day, right from midnight on August 18th to midnight August 19th. I keep accumulating all the orders that are coming in so that I can keep doing aggregates at every 1 second or every 10 seconds or every 1 minute. The dashboard will refresh saying that, okay, at 12, let's say the dashboard is refreshing at 10 minutes. At 12:10, this is the amount of orders I have. At 12:20, I have this. 12:30, I have this. But the data, it runs aggregates, it runs from 12 o'clock. Now, at midday or next day, 11:59, it will again run the aggregate, but this time it will run for the entire day's orders because I have the entire day as window. My entire data for one window is for 1 day is there in the memory. Right? Now, after 12:15 that day, now my window has changed. Then I will get new data. So the old data I remove. Or say it's a sliding window of last 24 hours.
No,
Which
what's
means
the purpose of this one here? Normally, just in this one, you want to see what's your sales from point to point. You want to see what is the purpose here?
yeah,
This
so
one.
live dashboard, right? It might be sales, or it might be the sensor data as you were talking about. It might be the sentiment analysis that we were talking about. So say my events run at so there is a live performance that is happening that is going on for 3 hours. So my entire event streaming data analysis that I want to take from all platforms, I will put it for the 3 hours plus the 3 hours after the show. That's when I see I get most of the feedback. So I put 6 hours. And as and when the data is coming in, I keep aggregating the good and bad reviews.
Okay.
And then I get real time, every 5 minutes or every 10 minutes, I get real time analysis of how the audience are reacting for the show.
Okay.
Let's say, so this is look at the data that is coming in at different time intervals, representation. So now I started streaming at T1. So this is Netcat. I mean, we can do this on the, your terminal where we can send the data in stream, kind of streaming data, Netcat. So let's say I'm sending these 2 lines, cat, dog, dog, dog. These are the 2 lines that I'm sending at T1. In my transformation, when I'm reading this data, what I am doing, I'm doing word count query, which means I'm taking these lines, reading both, splitting it into words, and aggregating by the count. How many times cat has appeared, how many times dog has appeared. This is my transformation. So what is the transformation here? Transformation is splitting the lines into words based on the by space. You take this line, split by space, and then put in the data frame. Here, so this is the transformation and this is the aggregation. What am I doing? I'm aggregating by each word, 1, 3. So how many times it has appeared? Cat has appeared once, dog has appeared 3 times. So this is at T1. Okay. At T1, my data will look like this. So I will write this to the table, and then somebody is reading the dashboard based on this table. So I get cat equal to 1, dog equal to 3. Now, still more data is coming in at T2, owl and cat. So since this is a unbounded table, this line gets added here. This is in memory. Okay. So don't worry. There is no table for this. This is a streaming data. Now, when I read again at T2 interval, I have all of this data to process now. Now, when I word count cat, dog, and owl, when I break it into the words, now I get cat, dog, owl, all of this. And when I aggregate count, cat has now count of 2. Here there is cat. Now again, there is a cat. This was here already earlier, but now we are doing again aggregates on the total data. All the data that has come in up to T2. So cat 2, dog 3, owl 1. Now more data is coming in at T3. So all of this here. I do word count, and then when I do aggregate at T3, cat is 2, dog is 4. One more dog word come in here. Owl, one more time here, so 2. Now at T3, this is my count. So let's say I keep my interval at 2 seconds. I want only, so let's say this T1, T2, T3 is hours, just for example's sake. This is 1 o'clock, 2 o'clock, and 3 o'clock. Now let's say I only want the aggregates or the data for last 2 hours. Assuming this is the window, this is how the data is coming in. Can you guys tell me what happens if I just define the window interval, also my window that I want for only last 2 hours? What is the data? At T1, T2, and T3.
So only T2, up to T2 it will come.
No, still T3 will also be there, but I want to only consider data for last 2 hours.
Okay.
Last 2 hours means 2 and 3 will come. 2 and 3 means we have owl and cat and dog and ball, and 2 owl, 1 cat and 1 dog.
Can you come again?
Summing of
Let's say T1.
T2.
So let's say T1. Let's say T1. What happens to this?
T1 means we have 1 cat and 3 dog here. T2
Okay.
means
So will it remain same, or does anything change?
It changes, right?
That means if it is overwritten, it will means if
No. See, at T1, I'm starting here.
Okay.
My total window aggregate, I want every 2 hours. I don't want any data before 2 hours. I want only for the last 2 hours. Now I started this now. So this data is within the 2 hours?
No.
Why?
Yes.
That's within 2 hours. That's the first hour data. You
Yeah,
can say.
this is first we are starting, first hour data. So there is no change here. Cat 1, dog 3. Now hour 2. What happens here?
2 means it's
So summing of T1 and T2
1 plus 2 has 2.
and average.
Right. Okay, good. So hour 2 also there is no change.
Yep.
Because I still want last 2 hours. So hour 1 and hour 2. So we'll still have cat 2, dog 3, owl 1. Now come to hour 3.
Okay,
What is the last 2 hours data here?
2 and
Does
3 is
it
the last
change?
2 hours data. Means so one is overwritten, right?
Yes. So here at this point, last 2 hours is 2 and 3. Only this is relevant to me. I don't want this. So what happens is this cat, dog, dog is gone. Only I will consider owl, cat, dog, owl. Where here, okay, the cat will be again 1, right?
One cat, one dog, 2 owl.
Yeah, cat will be 1, dog will be 1, owl will be 2. So at T1, cat is 1. At T3 also, the cat will be 1. Because we are moving the sliding window every 2 hours. So we are only considering the aggregate for last 2 hours. If I do 3 hours, this will be. If I do 10 hours, it will get more aggregate. Okay. So that's how the streaming window that you take works. And also, you can continuously keep appending this to your raw layer. You don't have to remove this or leave this data at all. You can keep continuously as and when every hour, keep appending to the your bronze layer. So your data will still look like this. But in the processing, if you just want to take 2 hours data, then you can do while it is streaming itself. Okay, got this? This is whole, we will talk about the streaming windows and sliding windows, how the data will be changing when you do the streaming. But this is the concept, you guys understand?
Yeah, you would say.
Yeah. Any questions? Manasa, Shanmuga?
No, Haru.
In real time, there are millions of records are going to add every 1 hour, right?
Yes. So that is why you have a trigger interval of 1 second.
At that time, how we are getting programmatically
Yeah, you can. How so at real time? Yes, that's how it's processing, right? Then you will have thousands of servers, clusters, data centers that are processing GPUs, right? So if you have Twitter or X data that is processing, how do you get trending? It does process all of those millions, right? Millions of records per second that is coming in, per hour that is coming in. So it's just a scale. You do small data in 1 second interval. So this is all like performance again. How fast you can process and how fast the data is coming in. If you are processing at a lesser speed than the data is arriving, then your data is getting choked up, backlog. Right? You're getting million records, but you're only processing 500,000. Your 500,000 is still waiting to be processed. And after that, again, 1 million. So it gets clogged up and then it'll fail. It'll break basically because there are too many. It'll go out of memory because too much data is clogging up. So what you can have to do, you have to either increase the interval or decrease the interval to process faster, or make your processing speed bigger. Right. So if you are processing at each 1 hour, and then there are million records, so you can try processing say every 10 minutes, so that you get 100K records, and then if you increase the processing speed so that you can process faster those 100K records, so that you are ready for the next batch in next 10 minutes. So those are the tuning parameters that you have to see based on the speed of data that is coming in and the speed of processing that you have. Right?
Nothing but like inflow and outflow.
Outflow, yes. Exactly.
Performance, yeah.
Yeah, but see, most of the time you don't get very huge use cases unless you are, as I said, right, Amazon or the Twitter, this kind of very few Netflix, this kind of thing, or the companies use cases where you get huge amount of data or sensor data, IoT data. There are a few use cases. General use cases, you don't get so much of data. It might be hundreds or thousands of records that are coming in each second or something, not more than that. And the use cases are also not so big, so detailed, right? So out of 10 use cases, one might be streaming use case, 8, 1 or 2 may be streaming, up to 8 may be your batch. Right? Batch, again, you can run the batch every 1 hour also. How many, it depends on how much you want to see live data on the dashboard, how much it has to fed into machine learning that give you predictions on the go. Like credit card fraud is one most apt use case, right? Credit card transactions that has to be processed streaming only. You cannot run batch. You have every transaction that is coming in. How you detect it if it is a fraudulent transaction? How do you block it? If I'm doing a transaction, sometimes you get a message that your transaction is blocked. If you want to proceed, you have to text some message to clear that. So how do you think that has happened? Because that is a streaming, right? Millions of transactions are coming in each second to the credit card processing companies, MasterCard or Visa. On the go, they have to try and see the behavior of that transaction. Let's say you have swiped that card now in Texas. Let's say in 3 minutes or 5 minutes, the same card is swiped in New York, right? So how it clearly means that the same person cannot be in 2 different places to physically swipe the card. How do you get that? How do you make sure that this is a fraudulent transaction? You have to make sure whenever you're coming in live, which geography or location, when was the transaction for the previous location, where was the previous transaction done, how far back it was, what is the time interval, right? So all of this, and then it's fed into machine learning algorithm saying that does this look good or not? If not, the algorithm will deny the transaction, send a decision, it comes back saying it's denied, something like that. So all of this will happen in the live. So that is where you get millions of records that you need to process real time and then do a measure, feed it to the algorithms, the machine learning algorithms to make decisions on this data. In a normal scenario where the sales data is coming in from different stores, and then I want to consolidate and see how much each store has done on a daily basis. So you can run a batch every 1 hour, taking data from all the stores and then writing it to the common table, kind of a thing, right? From different sources that is coming. So that is a batch thing. So that's why I said, like, the use cases for streaming might be 20%, 20 to 30% compared to the other things of 70. And when we are going in, mostly we will be working on the batch queries, mostly programs. As I said, 20 to 30% are the very serious use cases where you need heavy lifting for the streaming jobs. Got you? You good? Does that help answer you?
Yes, sir. Yes, sir.
Yeah. Okay. All right. Let's go back here. I don't know. Somehow strange.
Yeah, no, yesterday onwards it is happening for
Yeah.
me several times. I logged in.
Yeah. Everybody, is it? I'm trying to
Yeah,
get.
within 5 minutes it is logging out.
Yeah. I was also trying last night. Tried multiple times to set up this thing. I thought it is only for me. Morning, I thought it will be fixed, but from morning also I'm trying. It's going to do the same thing.
From past 3 days onwards, it will seem like that only. Yeah.
Oh, 3 days?
Yes, from Wednesday onwards. Yeah.
and I have not used them, this notebook, in last 3 days. Oh, my cluster is also detached. Oh, I have to create new cluster now. That is also getting disabled. Okay, this will take time. So until that is getting created. So you'll say you want to see this case, the simple streaming today, and then I will add more use cases for the next week for streaming. So what we are doing here, for the batch, we do spark.read, right? When you want to read, remember we have done spark.
Yes, sir.
In the batch. That is wherever you open any of this. Yeah, spark.read. Okay, and then we give the format, file type, schema, and all of this. So the same thing when you do streaming, instead of read, you do read stream, spark.read stream, and then you give the format. So format, as I said, can be Kafka, Kinesis, file based, or format rate. So rate is basically one utility kind of a thing that Databricks gives you, where it will generate the stream for you. It only has 2 columns. One is the timestamp, and another is the I think ID or something. Okay. Yeah, it will have rate. So rate will have 2 columns, on timestamp and one ID, and then you can give option how many you want to generate per second, right? How many rows you want to generate. Now, when you load that, again, you are adding your own columns to that stream, just like for the just like you have been doing for batch. Once you read this, you are adding column called loan ID. You are adding 10,000 plus whatever is the value that is coming in from here. So the rate will have timestamp and a value, right? So that value you are appending it to the adding it to the loan ID. Funded amount is some calculation again, some random integer, something, just to generate some random numbers. Paid amount is funded amount minus some again random number. So these are all some generating. So don't get overwhelmed by all of this. This is all not relevant. This is all just to generate some random values to these columns when you are creating. Okay, so this is the value. Value is just like some random ID that you get. Timestamp, and these are the 3 columns that we are generating when you are reading from the data. Loan ID, fund amount, and all of this. So then you can do a group by streaming data and do a count to see how the data is coming in, just like aggregates we wanted to do, right? So that is how it is. Simply setting this up, we are using a streaming source called rate, which you can see here. Let me share. Streaming source rate. Here. Should be somewhere in the documentation. This is Netcat localhost that I'm talking about, right? You can set up Spark on your local system, and then we can try this use case using from the Netcat. You can stream the data to socket stream. Okay, that's fine. Oh God. I think this is completely stopped now. I'm not able to do. I don't think we're not able to proceed with this. Oh. Any suggestions? Having any workarounds? Anybody?
I restarted a machine and it worked, but it happened same thing. Not like this. After a couple of minutes is happening, but in your case, every second.
Oh, sometimes it works. Sometimes it. See now it's okay. So let's run this before we get anything. Okay. So this is the stream data. Now when I do display, this is triggered. Okay, now it starts reading. See here, stream initializing. And then it starts reading from this stream called rate. So these are all the 5 columns. See, every time you go, keeps increasing. It's 95, 110, 115. That's 1 second data. See, the lag is basically how it is being displayed, but it is still reading at 5 rows per second. Okay. Now, when I do the aggregate count here, the same stream data. Now you'll see how it is aggregating, how the data is increasing. 35, 50. So these are all now it's the stream that is running, right? So you're doing aggregation, and then let's assume this is the actual sales data, orders data that is coming in. How many orders I'm getting per second or for 5 seconds. So you can just do this and we can also do this. What is this? This is the display query dashboard batch. How many seconds input rate? What is the processing rate that we are talking about, right, for the stream? Average and latest. You don't have to give much to this at this point of time, but just understand how the stream is continuously reading and updating this. So once you start this, it's on auto mode. You don't need to do anything. It keeps continuously reading the data. It keeps continuously displaying the data here. It keeps continuously counting this. Okay. So let's stop this one and say stop everything.
Arun, actually, this process will run continuously, right?
Yes, it will.
Okay.
Until you stop it. Oh, God.
So Harun, that format, how we decide depends on the system or
which format?
The format rate you define, right? Spark.readstream.format rate.
Yeah, you should know from where you're reading, right? Is it a file or is it a Kafka or are you reading from any streaming Flume or Kafka or Twitter or Facebook? So each streaming source will have that format type.
Okay, so we have some definitions in the Spark.
Yeah, Databricks, it will give you, right, what format options and the documentation you have. If it is Kafka, you just put here Kafka. Okay, if it is files, I think you can put files. I'll show you that.
Okay.
So this data one. Okay. I just read this stream data one. I'm not doing any transformations. So you will get only two columns, timestamp and value. That's what I was talking about. It keeps every, 5 rows per second. You can change how many rows you want here. Okay. So if you want 100, you can put 100 here. Stop this. And then run this again. And run this again. So it will start. 400 time it's more 700, right? So the speed of the data that is coming in that you're processing is more now. Got this? So I wanted to also do, okay, stop this. Wanted to go do the streaming one of files, so you can do. Okay, so there is another thing called, as I said, right, rate is one. The other streaming is files. Okay, so when you read files, you can still give the same format, read stream, and then format you can give CSV if you are reading the CSV files. Okay, or if you're reading JSON files, you can just put read stream, schema is JSON schema, whatever schema you are providing. Max files per trigger, how many files you want to read for each trigger, each triggering time. Dot JSON, you're reading the JSON file. So just like you're doing batch, you can also do stream, but you'll add these options, different options for this. One, you will say read stream. The other, you will say option max file trigger per max, how many files you want to read each time. So here again, Databricks has given the structured streaming events. This is basically a files which you have 50 JSON files here. So all of these files have, when you are reading the streaming, all the files should have the same structure. That's prerequisite. Otherwise you can handle, but still at a very high level, that is the requirement, prerequisite. When you are streaming, reading, basically what is streaming? You're getting the data into the same folder from multiple sources, right? From the same source at multiple times. You keep getting the files. The data is same, right? So the structure of the file will also be the same. Now we have here 50 files. Normally when we do batch, you can just read the batch, it will read all the 50 files at one time. Or you can do read stream, and then you can say how many files you want to read at each interval. Then it will read one file at a time. If you put one file, it will read one file. If you read 5, it will read 5 files at one time. Right? So here, this file has only, again, this file also has, the JSON file has 2 columns, open and, action and time. So action is open and close. Time is the timestamp. Again, you can read this and then do a group by action and count, just like we did aggregates, right? So you can have action open or action count, or aggregate group by action, and then you give the count. So how many, each time it reads a file, we have seen, right? T1, T2, T3. At T1, it will read file 1 and then do an aggregate of how many open are there, how many close are there. Then at T2, it will read second file, but it will aggregate both file 1 and file 2 together, how many open, how many close. Like that, it will go up to the 50 files to do the aggregations. I will try this one more time and we'll stop here. I don't think it's permitting to move forward. So you got this? One is the rate format we did, and the other is the file format we are doing for streaming.
Yeah.
Okay.
So rate format is nothing but the time weight based on the data.
No, rate will give you again two columns that we looked, right? How many records you want to read per second. It just gives you again two columns, value and timestamp. It keeps sending you the records, what you are reading. This is files you are reading as streaming.
So rate is just for testing, Harun?
Yes, it's only for testing. Just an utility to understand how streaming works. So in real time, you don't have rate. In real time, most of the times it will be files or it will be Kafka or other streaming. Files in the sense, it's called cloud, on the cloud, right? So Amazon S3 or whatever, Azure, where the incoming data is getting streamed as files. They keep writing the files in the folder every 1 second, 5 seconds, 1 minute, whatever it is. They keep dumping into that folder, and the stream will continuously monitor and read. Whenever there is a new file is coming in, it will start reading that file and process. Or it is like Kafka or Flume, where the sources that you read continuously that data.
So if it is a Kafka or something, so how do we get the connections and everything, the setup?
Yeah, that is all there in the configuration itself. The syntax is not a big deal in the data from where you see this is not allowing. You can go. You can actually search here. Spark Streaming, Kafka, example. Okay. You can open any of this. It has an integration guide automatically. Yes, you write format Kafka, and the option you do what are your Kafka servers, and what is the topic you are reading from.
Okay, here we will give that server names and everything, right?
Yes.
Host name. Okay.
This is where your Kafka is installed, right? So it will have some host and ports, Bootstrap server, host and port, and then you subscribe to a topic. So Kafka will have topics. So which topic you want to read from? Basically, there might be, say, orders data coming in orders topic. There might be the inventory information coming in inventory topic, or convert refunds data that is coming in, whatever. So multiple different types of data might be written to Kafka in different topics. And then you might have different streaming jobs processing different topics. So this job you might put which topic you are reading from. Okay. And then you can say cast key as string, value as string. You can type cast. Topic with headers, include headers is there. So you can subscribe to multiple topics. You can get data from multiple topics as well in the same stream. Or you can do all topics using a pattern. You can read. Okay. So it's just all you have to change is here your format and options. That's it. No special configurations and all of that. As long as you have access, and industry, you already have this. They will have credentials, secret credentials that are already configured that you can use them to connect. The credentials and options. It will also need your credentials to connect to Kafka, right? Username, password, and all of that. That will also be there. You need to provide that.
Okay.
Yeah.
So everything we can provide in the option, right? Like
Yeah.
it is
Yeah,
already
options,
password,
credentials also, yeah, will be there in the options.
if it is a key as well.
Yes. Okay. So I think it's not allowing. We'll have to figure out next week. We'll see if this still has an issue. I will try to see if we have the paid version where we can do this. I have a paid version as well. I need to check the credentials and log in and do that. So next week we'll continue doing this. This is the streaming events. And you have file. These are all the files you have, 50 files. And then if you take any file and display, you have these actions, open and close. Sorry, open and close the action type and the timestamp. Now here, reading as stream, schema is JSON schema. I've just put time, which is a timestamp type, and action is a string type. These two fields I'm providing as the schema. Input path is what this is the files that we have. Then I say read stream with this schema, one file at a time with at this path. And now when I say display, it will start the stream. So what is the action type and what is the count? For go up to all the 50 files. Open 1469, closes 531, keeps reading the file, one file at a time, and then process the aggregates. So you see the counts increasing.
So Arun, in real time, so these nodes will be always be open, right? Should be scheduled or something, right? Otherwise, we can't run any other queries or something.
No, these notebooks, you don't run any of the notebook manually. All of them will be scheduled using workflows. Jobs. You create a job, attach your notebook to the job, and then use that job in the workflows.
Okay.
Schedule it in the workflows. We will look at that. This may not be here in the paid version, I think. So we can create those and look at workflows. But you can see this, right? Count that is increasing.
Yes, yeah.
Okay, great. So this is the same thing you can do with your Amazon, your files also. You have that Amazon data set. I don't know if you have already downloaded or we have just done the movies till now. There's an Amazon files sales data set that you can download again from Kaggle. I think Subbu already has this. You can also share. Yeah, you can share. I can also share later. But it will have also all the files. So we can do the same files either batch or either stream. So you can do the stream and then you can get this. you can start loading. So we will see this next week. Okay, I'm not able to process this, but here you see file count. Gone. Okay, that's fine. So you got this right, at least the concept of what is how streaming, why streaming is useful, what are the use cases, what is the Spark architecture, streaming architecture, and reading from different sources like rate and files today.
I'm comparing with the I'm comparing with the batch process and the streaming process. In batch process, there is a Medallion architecture, 3 stages: bronze, silver, and gold. It is filtering data and aggregating data. But in streaming, like that, we are filtering the data, or only one stage, or directly.
No. Basically, see, Medallion architecture is the same. It's a concept, right? Whatever you're reading in batch, you can write. Whatever you're reading in streaming, also you can write to the same. The tables architecture will remain same. Bronze, silver, gold. You can still have the same architecture. You can write from the batch or you can write from the stream. In fact, you can write to the same table, both from batch and streaming. Both jobs can write to the same table. Okay. You can have a batch writing every 1 hour, and then you can have another continuous streaming data from another source that you are writing that can keep writing to the same table. Both can write to the same table. There is no limitation that streaming should have different tables, different architecture. No, that's the whole purpose of having unified Lakehouse platform is there's one platform where you can do streaming and batch in the same pipeline. The same batch you can just convert to streaming and run it. It should run as is with minimal changes. You don't need to change any architecture. You don't need to change anything. All you need to provide is your stream. Instead of read, you do read stream. Your options, what you want to provide, thus change, and you put to provide a checkpoint directory. As long as the schema remains same, the columns that you are getting and everything, it should still write to the same tables without any changes to the tables at all. You can change the job to streaming, or you can change the job to batch, or you can have both jobs, one streaming and one batch, both writing to the same table and at the same time also. Okay. And we can also see you can actually join the tables within the notebook, right? When the streaming data is coming in, and then there is a batch table, you can join these two live. The streaming data you can join with a static table, lookup table, and do a result data frame and then write it like you are doing in the movies data set, right? You have reviews and then you have movies. So the movies can be a static table. Reviews can be a streaming table. Now the reviews are coming in. You can keep joining that with the your static movies table, and then come up with the data frame and do aggregates of what is the average rating for that movie. And you can see how it is increasing or decreasing over the time based on more reviews that are coming. There you go, your use case for the streaming. That's it.
Basically, so after that,
stream and static join. We can look at when we talk about joins, we can talk about that.
So basically, this one we can make it as a table as well, right? Just like the batch. And after that, we can give the access to the analytics team or whoever wants.
Yes, definitely. There will be tables. You will not have everything here. When you're giving access to somebody, they will always read from tables only. All your downstream systems, again, when I said they have to, it's the standard. The standard way of any downstream system reading is from your gold layer, where you will have all aggregate tables. Okay, that will not change. Your sources, if they are streaming or batch, that will change. your notebooks, whether you have doing a streaming processing or batch, that will change. But you can still write to the same tables. Tables will not change as long as the schema is same.
Okay.
You might be doing a batch, say every 30 minutes or 15 minutes, but then you see it's not working for you. You just get more data that is coming in. So you might want to convert that batch job to a streaming job, right? So that you can process much faster. Or you say you have a streaming job and then you're not seeing much data that is coming in to process. Then you might look at converting it to a batch job to run every 15 minutes or every 1 hour. You can change either ways. And your architecture will not impact, it will not change. Your tables will not change. Your schema will not change. Your data will not change. That's the whole beauty of Lakehouse, where you can have both batch and streaming on the same platform, same tables, independently or together. You can merge both, independently or together. That it will not impact. Got it?
Yeah.
Okay. All right. So I think the classes must early release today. Okay. 10:45. Get 15 minutes back to your normal life. But go through this. I will publish this, and we will redo this next week, and then add more examples so that you're clear about streaming next week. Okay.
Thank you, Harun.
Yep. Thank you, guys. Any
thanks,
other
Harun.
questions before we wrap up?
I'm good.
Okay, great. So I might be not able to upload the video today, or probably I'll try end of day as I'm traveling. Most likely end of day today or tomorrow I'll upload the video.
Thank you, Arun, for taking time on a holiday.
Yeah, no worries. Take care, guys. Have a good day.
Arun.
Okay, bye.
Thank you, Harun.